Hello everyone, I'm Frank, and welcome to Learn How to Sudoku, where we take a very easy, very Sudoku puzzle, and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called 9 Rules by Alarark50. And here are the rules. We have normal 9 by 9 Sudoku rules apply, which means that every cell in the grid place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have German whisper lines, where along a green line, 2 adjacent digits must have a difference of at least 5. And we have Dutch whisper lines, where along an orange line, 2 adjacent digits must have a difference of at least 4. And I call these whisper 5 and whisper 4 lines because the setter came up with that name. And I thought it made a lot of sense because it's kind of obvious. It's very easily extendable. We have a whisper 5 line here, which means the difference between digits cells on the line must be at least 5. And we have whisper 4 lines here, which means the difference between adjacent digits on this line must be at least 4. So as an example, if this digit were, say, a 3 and this digit were 3, this digit here would have to be 8 or 9, because the only digits which are 5 or more away from 3 are 8 and 9. And this digit would have to be 7, 8, or 9, because these digits must be at least... the digits that are 4 or more apart from 3 are 7, 8, and 9. So that's an example of how whisper 5 or whisper 4 lines work. We have maximums and minimums, where digits in cells with 4 arrows facing inward are smaller than all orthogonally connected digits. And what does it mean to be orthogonally connected? It just means that the cells share an edge. So this cell has arrows facing inwards. So therefore, all the digits next to it that share an edge with it must be greater than that digit. Or this digit is smaller than all the cells that share an edge with it. That's another way of putting it. And digits in cells with 4 arrows facing outward are greater than all orthogonally connected digits. So that's in this example here, and this must be greater than all the cells it shares an edge with. So that's how minimum and maximums work. So that's rule 3, 4, maybe 3 and 4. It's just 3. We also have killer cages. The digits in cages add up to the number in the top left corner of the cage. So, for example, if this were a 2, this would have to be an 8 here because these 2 digits must add up to 10 because they have a 10 in the upper left-hand corner, and those are the only 2 digits in the cage. So this is rule 3 or 4. 4 or 5. I'm not sure which. We have Kropke dots, where a white dot separates 2 digits that are consecutive, and a black dot separates 2 digits such that one is twice the other. So, for example, if this were, say, a 2 here, this would have to be 1 or 4 to maintain a 1 to 2 ratio between them, because there is a black dot between them. If this were, say, a 6, this would have to be a 5 or 7, because these digits must be consecutive, because there's a white dot between them. So I'm guessing that then this is probably rule number 5. 6, 7, 8, 9. Yep. Okay, so we have 5. We have arrows, where digits along an arrow must add up to the total in the attached circle. So, for example, if this were, say, 3 and 5, this would have to be 8. Also, these digits along this arrow must also add up to 8, because otherwise, then the digits along the arrow wouldn't add up to the digit in the attached circle, which obviously is problematic. Anyways, that's an example of how arrows work. We have even and odd, where digits in cells with with gray squares are even. Okay, so that's another rule set there. That's rule 7, I guess. 1, 2, 3, 4, 5, 6, and 7. Yep. So these digits must be even because they have a gray square in them. We have a palindrome where the gray line reads the same way from both ends. So it must read the same going this way as it does going this way. So that's how a palindrome works. And we have a same parity line, where digits along the turquoise line share the same parity. So all of these are the same parity. They're either all odd or they are all even. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay. On a Whisper 5 line, the only two digits which are even, which can be 5 or more apart from each other, are 2 and 8. Right? 4 and 2, 2 and 4, 4 and 6, 2 and 8, 2 and 6, 2 and 4, 4 and 8, all are less than 5 apart from each other. So this has to be a 2-8 pair here. In addition, for a Whisper 4 line, to be in a 1-to-2 ratio and to be 4 apart from each other, the only digits that can satisfy that are 4 and 8. To be in a 1-to-2 ratio would be 1 and 2, 2 and 4, 3 and 6, and 4 and 8, but obviously the difference between all the other pairs are less than 4. So this has to be a 4-8 pair here. Well, for this set, to add up to 13, is 2 digits. It could be either 4-9, 5-8, or 6-7, but the 4-8 pair in the row eliminates 4-9 and 5-8 as a possibility. So this must be a 6-7 pair. That means the remaining digits in this row have to be 1, 2, 3, 5, and 9. Well, okay, couple of things. 4, well, one thing is this can't be 2, because we have a 2-8 pair in the box. We also know on a Whisper 5 line, you can never have a 5. Because if you subtract 5 or more from 5, you get 0 or less, which is not a normal Sudoku digit. If you add 5 or more to 5, you get 10 or more, which is not a digit. Also, on a Whisper 5 line, you'll always alternate between low digits, which are the digits 1 through 4, and a high digit, which are the digits 6 through 9. Obviously, 5 can't be on there because of the reason why I told you. And the reason why we know that we alternate between low and high digits on the Whisper 5 line is what digits can be next to a low digit, which are 1 through 4. 1 can be next to 6 through 9, 2 can be next to 7 through 9, 3 can be next to 8 or 9, 4 can only be next to 9, all of which are high digits. So next to a low digit has to be a high digit. Well, what happens if we look at the high digits? What digits can be next to that? 6 can be next to 1, 7 can be next to 1 or 2, 8 can be next to 1 through 3, and 9 can be next to 1 through 4, all of which are low digits. So next to a high digit has to be a low digit. That's why you always know we alternate between low and high digits on a Whisper 5 line. So, what's the only high digit here that we have available? We don't have 8 anymore, or 6 or 7, because of the 4-8 and the 6-7 pairs in the row. So the only high digit we have left here is a 9. 5 can't be on Whisper 5 line, so this has to be 9 here. It cannot be, so 9 has to be here, which means this can't be 9. Therefore, this is a low, which is next to high digits on the Whisper 5 line, which must be next to a low digit on the Whisper 5 line, which is next to a high digit. So 9 is one of these. And another thing, so 5, where is 5 in this upper left-hand box? All the digits are in Whisper 5 lines except for one cell, so the 5 has to be in that cell. So that means this is 5 here. Well, where is 4 going to be on these Whisper 5 lines? Because it has to be on one of them. It can only be next to 9, and the 9 can only be one of these two digits. So therefore the 4 has to be here and is low, which is next to a high 9, which is next to a low digit here. So this can't be 9 here. This has to be 9 here. This is an even cell, so that's 2, which makes that 8. And it's low. That eliminates 1, 3, and 9 in the rest of the row, so this becomes a 2, 5 pair. Remaining digits here have to be 6 and 7. Well, what digits can they be next to on a Whisper 5 line? Because we have 9 here and 8 here. 6 and 7 cannot be next to the 3, so this can't be 3, which makes this 1, which makes that 3. So then this becomes a 6, 7 pair here. Okay. This digit can't be 8. It's a sum of 3 digits here. So, or 3 unique digits here. Which means that that's going to be at least 6 for those 3 digits. And then this digit also has to be at least 1. So this is at least 7. It cannot be 8 because of 8 in the column, so it's 7 or 9. So this sum can only add up to 8 at most, which means we're guaranteed a 1 somewhere here. So it's 1 through 5, and we're guaranteed a 1 here. And this can't be 1 because of 1 in the column. This can't be 2 or 4 because of 2 or 4 in the column. This can't be 3 because of 3 in the column. And this is at least 6. 6 plus 3 at most adds up to 9. So this is 1, 2, or 3. These 2 digits must add up to 7 or 9. If it's 7, it can't be 2 or cannot include 2 or 4 because of 2 or 4 in the column. So this must then be 1 and 6 as a possibility, because 2 and 4 eliminate 2, 5 as a possibility, and 3, 4 as a possibility. If this is adding up to 9, we do not have 2, 7 or 4, 5 available because of 2 or 4 in the column. That just leaves 1, 8 or 3, 6. Okay, so those are the possibilities here. These 2 digits add up to 10. And they cannot have a 1 in them. And they can't have 6 or 7 because of the 6, 7 pair in the column. Oh, this digit can't be 6 because 6 cannot be next to 2 on a Whisper 5 line. So that's 7, which makes that 6. No 1, 9 here to add up to 10. No 3, 6. Sorry, no 4, 6 or 3, 7. So this has to be a 2, 8 pair. Therefore, we know this can't be 8 here. This has to be either 1, 6 or 3, 6, adding up to 7 or 9. So 6 is guaranteed here. 2, 8 pair eliminates 2, 8 in the rest of the column. So no 2 there. If we try to have 5 here, it has to be with 1, 2, and 5, but this can't be, the 2 can't be here, so 2 would have to be here, so that can't be 5. And then the 1 would have to be here, so that can't be 5. So now we have a 1, 3, 6 triplet in column 2 and box. This left central box. That eliminates 1, 3, and 6 in the rest of the box and column. That leaves this as what? We have 8 as a possibility. And 5 and 7. So this is 5, 7, 8 as a triplet. But this digit can't be 8 because that would mean this digit has to be 8 for this palindrome to work. Cannot be 5 either because of the 5 or the 8, because this digit would have to be 5, which would force that to be 5. And that's not possible because of 5 and 8 in the column. So this digit must be a 7, which makes that digit a 7. This cannot be 7 anymore. It's 9, which is the sum of 3 and 6, adding up to 9. That means this can't be 3, it's 1. That eliminates 1 here. So we can't have 4 here, because if it's 1, 4, and 5, that would force 1, 4, and 5 there, which would add up to 10, which is not equal to the sum of 9. So this has to be 2 here. And 5 can't be here because of 5 in the column, so this must be 4, which means on a palindrome, this must also be a 4. So there's no 7 here, no 7 here. 4 eliminates 4 here, so it's 5. 1, 5, and 2 add up to 8 plus 1 adds up to 9. So that's 1 there. 2 eliminates 2 here, so it's 5, which makes that 2. 5 can only be 4 or more away from 2 digits, 1 and 9. Any other digit, it's not possible to be next to on a whisper 4 line. So this has to be a 1-9 pair here. 4 and 8 are here. If 4 were here, the problem is 8 is already here. 4 can only be next to 8 or 9 on a whisper 4 line, but we have a 1-9 pair in the box, so this cannot be 9 here. Therefore, since this can't be 9 and it can't be 8, this can't be 4 here. That makes that 8 and 4 there. 8 can be next to 1, 2, or 3, but this can't be 1 because of the 1-9 pair in the box. It can't be 2 because of, aside from 4, I should say. It can't be 2 because of 2 in the row, so that leaves that as 3. Where is the 6 in this box? Can't be here, can't be any of these digits, can't be here or there, so it must be here. That leaves a 2-7 pair remaining in this box. Okay. Remaining digits of column 3, we have 3 and 9, but this can't be 3 because of 3 in the row. So this is 9, that's 3. Remaining digits of column 1, we have 1, 2, and 6. If any of these could be 1, 2, or 6. These are all the same parity, but this digit must be greater than that one. Okay, remaining digits of row 1, we have 1, 9, and 4, and 5 available. Row 3, we have 1, 9, and 3, 8 available. Row 4, what digits do we have available? We have 3, 7, 4, 6, 8. So no 3 or 8 here because of 3 or 8 in column. Same with no 4 or 6 there. This digit is greater than all 3 of these. Okay. Remaining digits of column 4. No 1, 2, 3, 5, 9. So it's 4, 6, 7, 8. Okay, no 4 here, no 7 here because of 4 and 7 in the row. No 4 here because of 4 in the row, and this digit is greater than that. So this is at minimum, sorry, it has 3 digits that it's smaller than, so this has to be at least, at most 6. This also has 3 digits that are uniquely, that are unique that it's smaller than. This has 3 digits that it's unique and greater than. So this has to be 6 at most because that has 3 digits possible. Cannot be 1, 3, or 4, so it's 2, 5, or 6 here. This can't be 3 because of 3 in the row. So we have 1, 2, 4, 5, and 6 possibilities there. This is greater than at least 3 unique digits. So it has to be at least 4, but it can't be 4 because of 4 in the row. So this is 5, 6, 7, 8, or 9. Okay. This digit is greater than that, but these are also both the same parity. So if this is greater than that, it could be 3. Cannot be 2, because 2 would then be greater than no even other digit. So it's 3 through 9 here. No 7 here because of 7 in the row. These digits are consecutive. Aha, okay. So here we have 4 digits which are all the same parity. If they were all even, that would account for all the evens in the column. But we have 2 digits here which are consecutive. You can only have an odd and an even digit that are consecutive. You can't have odd and odd, right? 1, 3 are not consecutive. 3 and 5, etc. are not consecutive. And you can't have even, because those aren't consecutive either. 4 and 6 aren't consecutive. 4 and 8, 2 and 8, etc., are not consecutive. So one of these four, if they were all even, you could not have an even here when we definitely have one. So therefore, these are all odd digits. We'll change this because we don't need that anymore. So these are all odd digits. One of these is odd, one of these is even, which means we have all odds accounted for in column 6, or column 8. So the rest of the digits must be even. So these are all even. This is 2 is even. This makes this a 6, and this makes this 4, and that makes that 8. That eliminates 4, 6, and 8 in the rest of the column. This can't be 2, it's odd. So we know the 2 has to be here as one of these digits. And 2 is only consecutive with 1 or 3. 3 can't be here because of 3 in the row, but still we could have 1, 2, or 3 here. These are odd digits. 6 eliminates 6 here, so that's 7. 8 eliminates 8 here. 4 eliminates 4 there. 7 eliminates 7 as a possibility here. Where is the 7 in column 8? Cannot be consecutive with 2. And it can't be here because of 7 in the row. Can't be here because it has 3 oh, this can't be smaller than that. This has to be greater than that, so therefore this must be 1 here, and this must be 2 here, which makes that a 3. That eliminates 3 there, so it's 7. This can't be 3, it becomes a 5, 9 pair. 9, if they were here, would not be smaller than any other digit, so this can't be 9, so that's 5, which makes that 9. That eliminates 5 and 9 in the rest of the box. No 7 here, no 7 in the rest of the row. 2 is here, that eliminates 2 there, no 1 there because of 1 in the row. These are both even because they are squares, 4, 6, and 8. Okay. These digits are greater than this digit here, so they mean have to be greater than 2, which and can't have 3, so this is 4 through 9 here. No 8 here, or 7, 9, because of 8, 7, and 8 in the column and 7, 9 in the row. So if this were 6, this digit would not be greater than it, so this cannot be 6. No 4 or 6 here because of 4 or 6 in the column. Where is the 1 in this lower central box? Because of the minimum here, these digits cannot be 1. And 1 can't be here because of 1 in the column. 1 can't be here because of 1 in the row, so 1 has to be here. That 1 eliminates 1 there, so it's 6. No 6 there, it's 2. No 2 or 6 there, it's 1. 6 eliminates 6 in the rest of the row. And this becomes 4, 5. So if this were 5, this digit would be a 4 and not greater than it. So this cannot be 5, therefore it's a 2. 2 eliminates 2 there, so it's 7 and 2. 7 cannot be 4 or more away from 9. So that means it can't be 9, it's 1, which makes that 9. That eliminates 9 here, 9 here, no 1 here, no 1 here, because of 1 in the row. What else? 4 eliminates 4 here. We have a 6, 8 pair in column 9, which eliminates 6 and 8 in the rest of the column. So no 6, 8 here. It's 3 or 4. This digit must be smaller than this and cannot be 5, 7, or 9. That leaves 1, 2, 3, 4, 6. And it can't be 8 because that would then force us not to be. That would be 6, but then that would be small. That would be smaller than the 8 that would be there. Okay. Remaining digits of row 8, we have 4, 5, and 8. Okay, this can't be 8 because of the 6, 8 pair in the column. So we have a 4, 5 pair left in row 8, which eliminates 4 and 5 in the rest of the row. So no 4 there, it's 8. 8 eliminates 8 here, so it's 6. That eliminates 6 here, so it's 8. No more 8 here. It's 2, which makes that 8. That eliminates 8 in the rest of these rows here. We have a 4, 6 pair in the central box. That eliminates 4 and 6 in the rest of the box. So this can't be 6, it's 7. 8 eliminates 8 here. We have a 3, 4, 6 triplet in row 4, which eliminates 3, 4, and 6 in the rest of the row. So this can't be 3, that's 8. Okay, this 4, 6 pair eliminates 4 and 6 in the rest of the box. 9 can't be here because of 9 in the row, so where is 9 in the central box? It has to be here. That eliminates 8 and 9 here. Remaining digits of the central box are 3 and 5 as a pair. That eliminates 3, 5 in the rest of the row. So no 3 here, it's 6, which makes this 3. 6 eliminates 6 here, so it's 4, which makes this 6. 6 eliminates 6 here, so this is a 3, 4 pair. That eliminates 3, 4 in the rest of the box, so no 3, 4 there. 3 eliminates 3 here, so it's 5 and 3. 5 eliminates 5 here, so it's 4. That leaves the remaining digit in column 5 as a 9. No more 4, 7 here, no 7 here, because of the 4 and the 7 in the column. 6 eliminates 6 here, so it's 8, which makes this a 6. 8 eliminates 8 there, so it's 5 and 8. 5 forces this not to be 5 there, so it's 7. That leaves that as a 5 there. Okay. No more 6 available here. Remaining digit in row 5 is a 6. Remaining digits in row 6 are 1 and 2. 2 eliminates 2 here, so that's 1, which makes that 2. 1 eliminates 1 here, so it's 5 and 1. Remaining digit in row 9 is a 9. 9 eliminates 9 here, so it's 3 and 9. That forces this to be 4 and 3. That leaves this digit as a 7, this digit as a 4, and that means this can't be 4, so it's 5. And that's the solution. Fairly straightforward. There are a lot of steps to go through, but I don't think the execution is that difficult. I think very easy satisfies that fairly easily. You can make a mistake, but it's kind of hard to if you realize enough about these rules. But maybe I'm so used to these rules. Maybe it's just I can easily spot when these rules have to change. I don't know. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and see you next time on Frank Puzzles. Take care.